Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Dear grade 4, for the one who were staying at home this week, okay, this video are made especially for you because there were some trouble in the laboratory, so you couldn't follow the lesson properly. So that's why I made this video for you. Before that, I apologize for the inconvenience that you got on that day. I didn't mean uh, it. Okay, I didn't mean it really because I I didn't notice that the speaker in the webcam is not working properly. Okay, but thank you for the suggestion and evaluation. Okay, I will try my best for the next hybrid learning. Okay, let's start. Wait. Okay. Okay, so our topic for the second meeting is about can solids behave like liquids, okay? And it's on your learner's book, page 56, okay? So you can read on your own, but let's read together. Can solids behave like liquids? Okay, so some solid, we prove some solid like the stone. We have done the investigation in the previous meeting. When we pour the stone, when we put the stone in different containers, the shape of that stone is still stays same, right? But how about if we use the other solid, the smaller solids? Okay, let's see. So can solids behave like liquids? We can pour a liquid. Can we pour a solid? Okay. Most solids are hard and cannot change their shape because their particles are packed tightly together. This means that we cannot pour solids like we can pour liquids. Okay. So yes, the way they flow, it's different. Okay. So that's why it is said this means that we cannot pour solids like we can pour liquid. Okay. And if you have ever explored your kitchen, you might find some solids that behave their behavior. I mean, they behave like liquids. Okay, some solids such as sand, flour, salt, and sugar are similar to liquids. The way they flow. Okay, we can pour them, and they take the shape of the container they are in. Okay, so when you pour some sugar into the jar and you try to make it full, okay, the shape of those powders, I mean the shape of the grains, sugar grains will be same as the jar or the container. The solids are sometimes called powders, okay? Powders. Powders dalam bahasa Indonesia itu bubuk ya. Okay, so almost all the solids that has very small grains and they can flow, they are called powders, bubuk. Powders are made up lots of very tiny pieces of grains. There is air between the grains, which means that the grains have space to move into. This lets the grains flow past one another like the particles in a liquid. But each grain of the powder is still made up of millions of particles that are too small for us to see. Okay, you might see the grain, okay, one single grain of the sugar. You can see it, okay, but if we compare to the particle of the liquid or the water, it will this grain, the sugar grain, is much more bigger than the particles of the water. Okay, and the single grain is made up of millions of particles. Okay, even though yes, these powders can flow or can behave like liquids, but they also what is it, their size actually is much more bigger than the size of the liquid particles or the size of the water particles. Okay? Okay, so why we did this investigation? Because this investigation is stated on your learner's book, page 57. Okay, so the aim or the objective to investigate solids that can flow. Okay, the materials that can flow usually we know as liquid ya. Oke, jadi bahan yang bisa mengalir itu biasanya cairan. Oke, oke. But we are here to prove that some solids can flow as well because they have very small grains. They are composed of very small grains. Okay, so we need a filter tunnel, a measuring cup or measuring cylinder, or I ask you to prepare plastic cups, beaker or jar, salt, sugar, flour, and sand. And also, actually, in the previous meeting, in our previous investigation, I would like to ask you to identify the size of the part of the grains by using a magnifying glass. Okay, but since we have no time, okay, just try to identify the size on your, I mean, by using your own eyes, I mean, without any supporting instruments. Okay, just okay, so I think for example, like, I think the flour grains are much smaller than the sugar grains, for example. Just try to investigate on your own. Okay, so place a small amount of each solid onto a piece of paper. Feel each solid. Does it feel rough or smooth? Okay, so the first instruction, okay, you have to put it on your palm. Put the salt by one, salt, sugar, and flour on your palm, and then feel it. Oh, I can feel this. The salt grains is quite smooth, but it's not really smooth. Okay, if I compare to the flour, okay, the flour, for example. Okay, observe each solid with a magnifying glass. No, okay, only observe with your naked eyes. Okay, without magnifying glass, that would be fine. Does the solid have big grains or small grains? Okay, just try to identify on your own, I mean, with your naked eyes. Okay, try to see and try to relate. Oh, miss, the smaller the grain, the smoother it feels. Okay, okay, that one later you can decide. Okay, and then measure 100 milliliter of a solid, or I ask you to prepare 2 tablespoons of each solid, salt, sugar, flour, and sand. Okay, and pour into the funnel. Okay, so in your science kit, you've got the funnel, and you have to measure how long it takes for the solid to flow through the funnel into the beaker. Okay, repeat the steps with the other solids and draw a graph to present your result. You don't need to draw a graph, just estimate. Okay, just estimate which one takes the shortest time to flow. Okay, okay, let's continue. Okay, so here is the detail. I have made a worksheet for you to be filled in. Okay, so this worksheet I have uploaded only the result in your Class Dojo. Okay, because in the worksheet mode I only can upload one page, so that's why I only upload the result part. Okay, but for this complete part I have attached the link in the instruction. Okay. Okay, so let's move on. Okay, so the instructions, I mean, the report are quite similar. Okay, the objective, you need to compare the size and then investigate how some solids can behave like liquids, or it means flow, and then how fast they flow, and the relation between the size of the powders and how fast they flow. Okay, so Actually, these are quite similar. I add tissue and plastic bag for you to clean up your desk if in case you are making your desk mess, okay? In a mess, I mean. Okay, so the method, pinch a small amount of each solid and fill it. Okay, so you put a little amount of the solids, I mean the salt, the sand, the sugar, and the flour on your palm, and then, oh, it's rough, miss, it's smooth. Okay, and then fill in results in D1. Okay, later we will go on D1. Observe each solid with a magnifying glass. Actually, I should demonstrate this, but because yes, since we don't have enough time, we didn't have enough time, so it will be okay if you just identify the size on your own, okay, by naked eyes. Okay, which does the solid have big grains or small grains? Okay, fill in the results D2. Okay, later we will continue to D2. Prepare 2 tablespoons of each powder. Okay, so you take 2 tablespoons and then hold the funnel over the plastic cup and then pour the solid into the funnel. Okay, estimate how long it takes for the solid to flow through the funnel into the beaker. Okay, I uh in our investigation last time, okay, many of your friends got problems to pour the solid into the funnel because some solids they get stuck. Okay, for example, some of your friends when they pour the flour, okay, because the space between the flour is very small, and also the flour grains is very small, very tiny. So that's why they when they have to get through the funnel, which is a small, like the small vessel, okay, they get stuck because the spaces are very small. Okay, so it's like they are solidifying. Okay, so some students get problem issue to pour the flour. Okay, but actually when we try to pour the flour little by little, okay, it will be the fastest one supposed to be. Okay, but yes, since the flour also very small and light, yes, so that's why most of the students get problem when they try to pour this flour. Okay, and the next one, sugar and salt and sand. Okay, be careful with the sand. Some of your friends also got problem when they pour the sand into the plastic cup because the sands contain what is it, pebble. Okay, ada kerikilnya, that's why, and the pebble makes the sand stuck and cannot get through the other sands. Okay, repeat the steps with other solids. Okay, so you have to repeat the steps with other solid. You pour one by one. Okay, the sugar, the flour, the salt, the sand, one by one. Okay, the order, it's up to you. Okay, let's go on, yeah. Okay, so this is the result that you have to fill in. Okay, the first one, write the number of the powders in order from the smoothest to the rough, to the most rough. Okay, so when you fill the, oh miss, for example, miss, I think sugar is the smoothest one. Okay, just write number 1 here, and then miss, I think the second one is the salt. Okay, the third one is the flour, the fourth one is the sand, miss. Okay, just write down this. Okay, write down the number 1 2 3 4. Okay, and I have uploaded this in your Class Dojo, and you just need to write down 1 2 3 4. Okay, the order is different, of course. This is just examples. Okay, I write 1 2 3 4. This is just examples. Okay, same as D2. When you observe the size of the powders, okay, from the smallest to the and here I ask you to put them in order from the smallest to the biggest. Okay, so you also write the number. Oh miss, I think sugar is the Second one, miss. The first one is the salt. Okay. The third one is the flour, and the fourth one is the sand. The biggest, yes, it means the biggest substance grains. The biggest grain is the sand. Okay, that's fine. Let's see. That's your observation. Okay, so I will not. Later we will discuss the result. Okay, just try to do it on your own based on your investigation. Okay, I appreciate each work that you do. Okay, so let's go on to part D3. Write the number of the powders in order from the fastest to the slowest flow. Okay, so when you try to pour them through the funnel, okay, which one? Oh, miss, the sand is the fastest one, miss. Okay, miss, I think the sand and the sugar, both of them are the fastest one. Okay, you can write down number one here. The second one is the flour, miss. Okay, and then the third one is the salt, miss. Okay, that's fine. It's okay. But, miss, okay, the salt is the first one, the flour is the second one, the sugar is the third one, okay, and the sand is the fourth one. Miss, I cannot estimate the time, miss. Okay, just if you cannot estimate the time, you can write the orders from the easiest one to flow to the hardest one to flow. Okay, the easiest one, they supposed to need the shortest time to flow. Okay, so yang mana yang paling gampang? Yang paling gampang dituang melalui corongnya itu yang mana? Okay, miss, if you cannot estimate the time. Okay, oh miss, yang paling gampang yang salt, miss. Okay, and then setelah itu yang floor agak susah, miss. Okay, you can put the floor into the last as the last number. Okay. Okay, and the last one, the conclusion. Circle the correct ones. Okay, so or underline the correct ones. So, do you think the sugar, salt, flour, and sand can behave like liquids? It means that they can flow. Okay, if you compare to the bigger solid, can they flow? Do you think can or cannot? And then behave like liquids. This is referred to to flow. Okay. So it means if in the first number you say it can, so the second number is supposed to be same. Okay. And there, which one is the smoothest among the powders? Sugar, sand, salt, or flour? Okay, and which one is the smallest substances among the powders? Flour, salt, sand, or sugar? And then which one is the fastest to flow? Okay, do you think, is there any relation between the size of the substances and how fast they flow? It means that, oh, miss, the smaller the substance, the faster they flow. Oh, that's how you relate the size and how fast they flow. Okay, or miss, the bigger the substance, the bigger the grain, the faster they flow. Okay, so it means there is relation. But you think, miss, there is no relation. The flour is the smallest one, and I don't think how it flows. If we compare to the other, it can be number two, or number three. Okay, that's fine. Okay, just try to answer it based on your observation. Okay, that's all actually for the investigation this week. Okay, for the one who didn't join the school face-to-face learning at school, I hope this video can help you. Okay, if you have any question, or miss, I still don't understand, miss, what is actually the purpose of our investigation? Okay, so let's back to the first sheet. Okay, the first page. It is said that to compare the size of powders and then to investigate how some solids can behave like liquids. Can behave like liquids, specifically can flow like liquids. Okay? And can take the shape of the container like liquids as well. Okay. That's all. Okay. For the explanation, I hope that next week will be better. I will try to fix everything, and I will try to fix the microphone in the laboratory, to set up the microphone as well, so that if your your friends which come to school, they are going to the laboratory, and then I hope that you also can do your demonstration. Okay, let's learn together. Okay, let's overcome this hybrid learning and this pandemic together. Thank you very much. Wassalamualaikum warahmatullahi wabarakatuh.